So far we have seen what a tablespace is, and the tables are created inside a tablespace. But tablespace is also made up of something called as data files. Data files. So we need to now thoroughly understand the correlation or the relationship between the data files and the table spaces. So now I'm going to draw another diagram. This is my hard disk. Okay, this is my kind of favorite diagram. This is my hard disk, and there is on the hard disk is usually a C drive or D drive. So let us say this is my C drive. There is one file. Now everybody is aware of what a file looks like. I mean, if I go in Windows Explorer, I can see a file there, and I can immediately see the size of the file. If I am on Unix, I can type the ls command and I can see the size of the ls-l. It will show me the size of the file. So we know what a file is. We can find out very easily the size of the file is. So let us say this is a file whose name is ps or let us say fin data1.dbf. Okay, it is sitting inside the C drive, and then when I say that this is a data file, the size of this data file is 1 gigabyte. This is what is sitting on the hard disk, and then inside the database on the operating system, I call this as a data file, but inside the database I call this as a table space, and the name of the table space I call that as a fin data, maybe fin data or data. The file is findata.dbf, and the name of the table space inside the database is findata. So there is a relationship between the file and a database. What I would say now that a table space findata is made up of one file called as findata1.dbf. The name of the file and the name of the table space is different here. Okay, this is findata1.dbf and this is just findata. So let me repeat what I just said. A table space is made up of a data file, and now I am going to say a table space is made up of one or more data files, one or more. So right now this is one. Let us say there is another data file. The name of that data file is findata2.dbf, and the size of this data file is only 500 megabytes. This is 1 gigabyte and this is 500 megabytes. Combine these two data files will create my table space findata. So earlier I was drawing only one square for the table space, but now my table space is really two data files. And what is the advantage of this? When I say that please back up the table space findata, you are going to make a copy of these two data files and keep it somewhere else, and that is what I'm going to call as a backup of my table space. So when I say backup my table space, you are going to go and first find out, oh, what is the name of the table space? Findata. Then you will somehow figure out what are the data files in that findata table space. You will have to go and see one data dictionary view, and once you know the names of these data files, you are going to make a copy of them either using the copy command on the DOS prompt or either using the cp command on the Unix machine, and that is going to be the backup of my simplest way. There are complications to that, but in the simplest way, that is going to be the backup of my table space findata. That is going to be backup of my table space findata. So what is the size of my table space now? Findata. What is the size of my table space findata? It is 1.5 gigabyte. Okay, it is made up of two data files. And now I am going to just my table space now is this. This is my table space. Okay, my diagram is not so good, but combined together is my table space now. So now I am gonna get rid of the distinction, and now I'm going to say, okay, this is my table space which is of size 1.5 gigabyte, and in that table space I'm going to create a table A, and the first extent of that table, the initial extent of that table space will be created here. The next will be created here, and the next will be created here, and so on. And my table A will be sitting right next to your B tables extents, and then again my table A's extent. So all those things are right next to each other, and when I take a backup, I will copy these two data files somewhere else. So this is now the correlation between the data files and the table space. So the same diagram that I drew earlier, I'm going to kind of put some additional things in that, and that will be like this. table spaces. Table spaces are made up of multiple data files. Okay, the remaining things are still the same. Table spaces are made up of multiple data files, and in the table space there is a actual table, but in reality where is the table going to be stored? Finally it will be inside the data file. So don't think that this and this is a totally different thing. When you are creating a table inside a table space, in reality it is getting, inside the data file. So it's like this, we have one building here. A building is divided into floors. I have multiple floors will make up a building. So multiple data files will make up a table space. And now I say that I have I have purchased one flat in that building. It means I have purchased a flat in one of the floors in that building, which I don't really have to mention. But that is how the whole things are. These are the floors, you can say, this is one building. If you like this analogy, keep it, otherwise throw it out. Multiple data files will have, or one or multiple data files will actually create one table space, and a table will be inside a table space, and therefore table will be inside a data file.
Many to one.
Many to one, that is how it is. Many to one to many, one and the same thing. Again, these are not tables, so we really should not be talking about the relationships into one to many, but this was for our understanding. Now another important data dictionary view is DBA underscore data underscore files. This is a very important data dictionary view, and I use this very frequently. What information is there in this DBA data files? There is a name of the table space that is there. Then the name of the data file, that is also there. And then there is a size of the data file, that is in bytes there. So these are the three important columns which are there in DBA underscore data underscore files. All data files. So let us say now, let us say we have a database called as focus 1. I will now erase this thing and draw another diagram, but draw another diagram. These are the three main columns, and there are quite a few other ones. We'll come back to those later. So this is our logical view of focus 1, and this is our physical view. Okay. Focus 1 has, let us say, 3 different table spaces. So this is a table space which is made up of 2 data files. This is a table space TS1. This is another table space TS2 made up of only 1 data file. Okay, and the sizes could be different. The size of this is 100 MB. This is also 100 MB. Size of this is suddenly 200 MB. This is one data file table space, and the third one is maybe very small, and it is made up of one data file itself, maybe TS3. So how many data files do we have in my database? Data file number 1, data file number 2, data file number 3, and data file number 4, and the size is only 10 MB. So 4 data files in my table space. How many table spaces are there? 3 table space, TS1, TS2, TS3. And what is the size of my database? 100 plus 100, 200, plus 200, 400, 410 is the size of my database, which is the collection, or which is the sum of all the table spaces in my database, which is again the sum of all the data files in my database. So data files, table spaces, and a database. This is how the correlationship is. Now there are schemas, schema A and schema B. Okay, now I'm going to get rid of this distinction here. Schema A is creating all of his tables over here, and schema B is creating all of his tables over here and some of his tables over here. So anybody could be creating tables anywhere else. The first table of schema A is here, and the first table of schema B is here. So my table and your table could be sitting right next to each other, and these are extents, and within extents there are blocks, and within blocks there are rows. So I think now, after so much of discussion, we should be very much clear about where are rows sitting, where are blocks sitting, where are extents, where is table space, and all that. This is very important to understand, and also the data dictionary views. Let me see if I have missed any points over here. Okay, so this is it. In the next kind of segment, next section, I will talk about how to create tables.